Right. So in previous lecture, we started chapter 4 that was about the moment of force. And in previous class, we discussed how can we figure out the moment or torque of a force in 2D as well as in 3D. So let's continue. In today's class, we'll start from the principle of moments. Right. Let's say if we have like let's say F1, F2, and moment arm, right? This was the and how can we figure out the moment arm, right? That's very simple. That out of these two forces, we can figure out a resultant force F, and then from the point we need a moment arm R. In terms of the three dimension, basically we need both the force vector in terms of vector as well as the moment arm as a vector, whereas this moment arm will be calculated in terms of position vector. So you can see that this is R cross F, the cross product. This is the position vector, this is the resultant force vector, whereas this resultant force vector is basically the sum of F1 and F2, and if we separate that, that will be R cross F1 plus R cross F2. Or in terms of let's say we also saw that in terms of scalar component, if the force is at uh, in such a location that we cannot have the perpendicular moment for this force, then what we can do, we can split this force into two components. For example, this is the force of component, let's say Fx, one of the component Fx, and then one of the component Fy, and then this vertical component will have perpendicular moment about O. Similarly, this horizontal component will have perpendicular moment, this one, right? This is the one, because if we use this force F, then predicting perpendicular distance like this one D is very difficult. Practically, this is very difficult to measure. So that's why the other convenient way is to split this force vector into two components, one along the x-axis and another along the y-axis. So in this way, each component, let's say for example Fx, the arm for the Fx is y, so and the direction of movement is clockwise. So the moment because of that Fx will be the clockwise, so that will be negative. Whereas the force Fy, the moment will be like this one, that x. Whereas the moment direction is counterclockwise, so we'll take that as a positive value. So this will be the moment of force, this F about O. We have separated that Fx into Fy, and then each moment related to each component is calculated, and that will give you the moment of that force F. Now let's try to apply this moment principle. For example, in this example, let's say the tool at position A, this is the tool, right? And at position A is used to hold a power lawn mower blade stationary. So you want to keep that lawn mower stationary by holding here, and let's say the force is applied F, and various dimension of that force is given. The angle, this is 12, this is 5, and the overall is 13. While the nut is being loosened with the wrench, so whereas another a wrench is used to loosen that nut and another force is applied, so this force keeps the lawnmower stationary, while this wrench apply in opposite direction. This, if you look at the direction, like this force produces a counterclockwise moment, whereas this force of 50 Newton, it produces a moment in the clockwise direction. So basically they are opposite to each other. Now the question is, if a force of 50 Newton is applied to wrench at B, at B in the direction shown, determine the moment it creates about the nut at C. So you have to figure out the moment of this force 50 Newton about point C. So basically you have to figure out what is the moment about point C because of the force 50 Newton, right? And then what is the magnitude of the force. Then you have to figure out the magnitude of this force at point A. And this is point A. What is the magnitude of that force? So that it creates the opposite moment about C. So the moment created by this force, 50 Newton, is equal in magnitude but opposite in direction, because this is in the counterclockwise whereas this is in the clockwise direction. So both moment will be equal. So first of all, you have to calculate the moment of this 50 Newton force about the point C. So what we can do, again, this is not, I mean, oriented in such a direction that we can take simply the horizontal component or vertical component. Basically what we can take is, we can take one of the axes of this one and another axis we can take along that range, right? And then if we take along that range, then we can split this force into two components. One of the component is the like the vertical component. Let's say this is the vertical component, right? Vertical component. Let's say this one is the vertical component, and then one component which is horizontal, I mean along that. So this will force will have two components, one perpendicular, I mean parallel to this axis, another one is along that point C. So basically the moment because of this component is equal to 0, but there will be a moment above for this force, I mean parallel to this force we can draw basically here, right? So I mean if this angle is 60 degree, I mean if this angle is 60 degree, that means, I mean this angle is basically 60 degree, then this component is basically 50. What is the value of this component?
Sin 60.
What is the value? Yeah, yes, sine
Sin
60,
60.
because it is in the front of the angle. So this is 50 sine 60, right? So that means this component will produce, and what is the distance from this position for, I mean moment arm for this force? That is 0.3 meter. So what will be the, and what is the direction of rotation because of this moment? That's clockwise, right? It will produce a clockwise torque. So that means 50 sine 60, 50 sine 60 multiplied by this 0.3. So that will give you the moment about C. I mean the other component of this force, which is this component has no moment arm because it is along the axis of the C. So this will create zero moment. So that's why there is
Excuse me,
the
sir.
only, yeah.
सर मोमेंट आर्म में 0.3 प्लस 50 cos 60 नहीं आएगा?
50
प्लस 50 cos 60 प्लस 0.3.
how?
सर कॉल उसका जो 50 न्यूटन हमारी फोर्स है उसका हॉरिजॉन्टल कंपोनेंट जो है वो 50 cos
No,
60 है ना
basically ये
मोमेंट
है
आर्म के अलोंग.
that I got your point. Basically this is 50 Newton. Now we can resolve the component. One component is like the vertical component. Let's say this component, right? And the other one is this component, right? So basically we know that this component is in front of the angle, right? I mean if we draw parallel to this component, here we can draw parallel to this component, right? So that means if this angle is 60, then mean this is parallel to this one, right? So this is basically 50 sine 30. So this is basically the point of application. So from point of application and from point C, the distance is 300 millimeter. You got the point?
यस सर.
Right. I think you were confused because I have drawn this force maybe here. Basically, this is parallel to this force. We have to see the point of application of this force. So here you can see the point of application of the force is at point B, right? This is point B. So at point B, you can see that. So vertical component and horizontal component. So basically vertical component will create here a torque, that torque. So that means for the vertical component the moment arm is 300 millimeter, right? So this was the moment about point C. Now we know that now we have to figure out this force. We want to calculate this force. Again, for this force, it will have two components. One component will be, parallel to this axis, right? And the one component will be perpendicular to this. Parallel to this one, right? Or we can also, instead of here, I can draw along with the force. Here, but parallel to this line or this axis. So now, which component will have zero moment? This component, because this component is along the line of action of, let's see. So this component will create no moment, but this component is perpendicular to this arm, to C. So this has a moment arm of 400 millimeter. But what is the value of this component? Since this component is parallel to 12, this component is parallel to 12, so 12 by 13 multiplied by f, right? Multiply by f, right? So this will be created by that component, right? So similarly, the moment created by this component is equal to the moment created by that vertical component, and that moment we just calculated. So if we equate those moment, moment of C, which we calculated earlier, then we can calculate the value. You can see that. Let me show you the value by calculation. For example, this was the moment about C that we calculated, this one, by using that vertical component. So that value was 13 Newton meter. Now when we come to the force F, now this component, vertical component, has zero moment, but horizontal component has certain moment. So we can equate that, like MC is equal to, since sum of is equal to 0, or we can equate like 12.99 moment is equal to the moment created by this force, which was 12 by 13 into F into perpendicular distance. What was the perpendicular distance? 0.4. So from here we can calculate that force. That force was equal to 35.2 Newton. So you got the answer? You understand?
Yes, sir.
So if you have any question about this. Right, so let's continue another one. Now here is a similar example. Let's say the tow line, this is the tow line, exert a force of P which is equal to 4 kilonewton at the end of 20-meter long crane boom. So this is a crane and this is the boom of the crane. So the length of the boom is given 20 meter. So the length of the boom is 20 meter. If x is equal to 25, where is x? This one. So this x is equal to 25 meter. Determine the position theta of the boom. So what is the position theta of the boom? So that this force creates a maximum moment about point O. So where is point O? This is point O. So this force, the force is 4 kilonewton. So this force creates a maximum moment. So what is this moment? First of all, you need to calculate what is the maximum moment, and then what is the value of this theta at maximum moment, right? So when is the this force will produce maximum moment? What do you think? When this force 4 kilonewton will produce maximum moment, when is possible?
At 90 degree.
At 90 degree, yes, you're right. When this angle is basically 90 degree, then this will produce maximum moment. So what is the maximum moment about point O? The maximum moment will be the force and the perpendicular distance. So the perpendicular distance is 20 meter. So 20 meter times that force, which is 4 kilonewton. So that is equal to 80 kilonewton meter. So 80 kilonewton meter. So that's the maximum torque. Now At this maximum torque, we need to calculate that angle. We know this angle is 90 degree, but we don't know this angle. I mean this angle. We don't know this angle. What is that angle? So once we will know this angle, we already know 90 degree, then we can calculate the angle theta. So how to calculate this angle? I think we can calculate this angle by, since this is a force, I mean this is a force P, right? This is the line of action of the force P. So we can, this force can have two components. One component is along x-axis, let's say Px, right? And I mean here, and the one component is along the y-axis, right? The component which is, I mean this angle is phi, let's say we given the name phi, right? So this is P, P mean 4, so P is 4 cos phi, and this component, vertical component, is 4 sin phi, right? So let's try to figure out the value, I mean that value of I mean we know the value of the moment about O is 80 degrees. So let's take the moment about O, let's say moment about O. So because of these two components, so the moment because of this component, what will be the moment arm for 4 cos theta? What is the moment arm about O?
1.5.
1.5. Good. So 4 cos theta, 4 cos phi multiplied by the moment arm, 1.5. So what about the direction? What is the direction if we use this moment arm?
Counterclockwise.
Counterclockwise. So this will be positive. And then this component 4 sin phi, then the moment arm for this component about point O is x, and the value of x is 25 meter, and the direction will be clockwise now. So this will be negative. So negative 4 sin phi times 25, and we already know the value of moment about O. We calculated that was 80 kilonewton. So using that formula, we have only one unknown in that equation, which is phi. So we can calculate the value of phi. So if you simplify this, you can calculate the value of phi, and then we know that in that triangle, the total angle is equal to 180. So if we can calculate that angle phi, and 90 is there, we can calculate the value of the theta, right? So here we first calculate the maximum moment, which was equal to 80 kilonewton, and then we calculated the value of phi, which is equal to 56.43, and then lastly we can calculate the value of theta, because one angle is 90, so and one we calculated is 56.43, so the value of the angle is 33.6 degree. So do you understand?
Yes, sir.
Right. And then in addition to calculating the moment about a point, we can also figure out the moment of a force about specified axis. I mean, we can calculate the moment about any axis if we know first the moment about a point. Let's try to understand this. Let's say we have a tire here. Let's say we want to tighten or loosen that tire, then we apply I mean that tightener wrench here. Let's say the hand apply force in the vertical direction, then the moment is produced about point O, right? And we know that to calculate the moment about point O, we know that we need R cross F. We need to know the R cross F, and then we can figure out the moment about point O. Whereas R should be in the vector form, as well as the force should be in vector form. And we know how to, there should be a position vector, let's say that D, and this should be in vector form in 3 dimensions. Similarly, this force vector should be in 3 dimensions. But let's say our our objective is to figure out what is the value of the moment about this axis. Let's say we are interested to figure out the moment about y-axis, right? Or any other axis. Let's say here we can can have any other axis. Let's say about x-axis. We are interested to figure out the moment about x-axis, right? But we know this is the moment about the O, the point O. So how to calculate the moment about any specified axis? So there is a rule for that. We know that the rule is that, let's say we want to calculate the moment about y, then we have to take the dot product between that axis and the moment about the point. So moment about the point we already know, that is equal to r cross f. So j dot r cross f. So that will be the value of the moment about the y-axis. So let's say I, I'm asking from you, what is the value of the moment about x-axis? Let's say, what will be the value about x-axis?
I dot mo.
Yeah, I dot mo, right? And mo is further equal to r cross f. So basically, in short, we can say if we know the moment about a fixed point, let's say O, then further we can figure out the moment about any axis, whether that axis is x-axis, y-axis, or any axis which is even not perpendicular, since x and y in this case is perpendicular, but that could be any axis. Right, let's generalize this concept. For example, if we have a force F, let's say this is a force F, and the line of from the moment from the fixed point, let's say this is the moment arm R. So what will be the moment about point O? That will be R
R
cross
cross
F.
f.
Yeah, R cross F. But if we are interested to figure out the moment about any axis, let's say this is an axis A, then what will be the value of the moment about the axis A?
R cross f
Yes.
dot ua.
No, that's wrong. UA dot UA dot R cross F, because moment is a vector. So there is a difference between R cross F dot U and U dot R cross F. So the correct way will be,
लेकिन सर डॉट प्रोडक्ट तो कम्यूटेटिव नहीं होता.
yeah, I mean you have to, within that I'm talking about this one, R cross F. So you have to carefully take into consideration, and then you can take the dot product. Yes, dot product is commutative. You can take whether this value first or this value first, right? So you can say that this is, let's say, UA dot R cross F. And how we figure out this one? How we figure out that? I mean, for three case, I mean, you can simplify, or there is a simple way to calculate this value, because this method is very tedious. I mean, the above method. I mean, opening the matrix, as I explained yesterday, opening the matrix is very tedious. Like first you have to take the I component and then minus j and then k and then simplifying. So this takes a lot of time. Instead of using this method, simply if you want to calculate UA dot R cross F, so first write down the because this is a vector. So just write down the three component of the first vector, then the three component of the second vector, then the three component of the third vector, and then you simplify, right? Using that matrix method, right? So this finally this will give you some scalar value, right? Why this will give you some scalar value like 50 Newton meter, 100 Newton meter? Why a scalar value?
बिकॉज सर डॉट प्रोडक्ट है तो
Yeah, because
उसका
this
आंसर
is a
स्केलर
dot.
होता है.
Yeah, so that means it will give you some just the magnitude, and how to get the direction of that moment. Then you need a unit vector. So the unit vector that you calculated, you have to multiply the scalar value with that unit vector. Then you will get again the moment and the moment of magnitude as well as its direction. So let's try to practice few numerical problem related to this concept, how to figure out the value of the moment at various specified axes. For example, this is the hood of a car, any automobile, which is supported by a strut AB. You know that when we open that hood, there is a strut that we normally support at point B. Right. So let's say it start from A to B, and let's say the strut apply a force F. and various dimensions are given. For example, if we take that as an origin, from origin the point A is located at various distance. So we know that from here to here is 2 feet, and then from y-axis to this point this is 4 feet, and then again from here to here is 4 feet, and the vertical height is again 4 feet. So based on this, the question is figure out the moment of F about the hinge axis Y. So basically we need to calculate My, right? Basically we need to calculate My, but we cannot calculate directly My. First of all, we need to calculate the moment about the origin. Let's say origin we say O. So first of all, we need to calculate the moment about O, right? And we can figure out the moment about O by taking R cross F, right? R cross F mean we need the force, this force in a vector form, as well as the moment arm from the origin to any line of action on that force. So I think R is very simple in that case. What is the value of R in that case? Yeah, what is the value
4i
of
minus 2j.
4I minus how? I mean from origin, if you start from the origin, you just move on the x-axis. So this is, you start from the origin, you just reach at point A. So this is
Only
basically
4i.
only 4I. Yeah, only 4I is the momentum. And then we need to figure out the force as a vector. To convert this scalar value into a vector, we need a unit vector. So that means from A to B, we need first a unit vector, but we cannot get directly a unit vector. We need first the position vector, and then we'll divide that position vector with its magnitude, and then we can calculate a unit vector. So that means first of all, we need the coordinates of A. The coordinates of A is 2, 2i comma 0 comma 0, right? And then the coordinates of B, what are the coordinates of B?
2i 2j plus 4k.
uh, Coordinates of A, that's 2I, yeah, you are right, 2I, and then how much is the distance here?
2.
uh, 2J, yes, and then 4K, yeah, right. So these are the coordinates of B. So then you can this is, I mean, let's say RBA,
सर
RBA, yes.
सर ए के कोऑर्डिनेट्स 400 नहीं होंगे 200 की जगह
जी 4 सॉरी, वो हमने पहले भी 4 ही लिया था, दैट्स 4,0,0,
यस
यू आर राइट, 4 कॉमा. So then we can get our b slash a equal to this minus this. So 2i minus 4, so that means minus 2, and then that's 0 0, so 2j plus 4k. So that will be the value of the position vector. Then we can get the value of its magnitude, right? You know how to get we have to take the square root, and then we can get the unit vector. So once you get the unit vector, then you can get the force vector. I mean, you multiply the value of that force F with the unit vector, so then it will be a vector, and then finally you can get m naught, right? But we don't need to get the m naught. Basically we need to calculate the moment about the y-axis, and the moment about the y-axis is basically, we have to, I mean, about an axis, that will be j, right? Because we know that the unit vector along the y-axis we called it as j, so that will be j dot r cross f, right? So that means again you have to take the component of the j means 0, 1, 0, and then the r, rx, ry, rz, and then the fx, fy, fz. Right? So you can solve, first of all we get the value of the r, then we converted force vector, then in order to calculate my, we need j dot r cross f. So for j dot cross of f, we need to put the values, and then if we simplify, so we'll get minus 78.4 pound feet. And the negative sign indicates that, what the negative sign indicates?
Counterclockwise.
No. Any other?
clockwise
Clockwise. Basically,
Oh,
we discussed in the first class the sign convention. If the moment is in the clockwise direction, this will be considered as negative, right? Whereas the moment in the counterclockwise direction, that will be considered as positive. So we'll follow this sign convention throughout this book. Counterclockwise as positive, clockwise as negative. Right. So let's try another one. For example, if the tension in the cable is 140 pound, determine the magnitude of the moment produced by this force about the hinged axis CD. So now hinged axis is no more an x-axis or y-axis or z-axis. So basically what you need is you have to figure out the moment of this force about this axis. I mean, what is the effect of this force? Because this will create moment, but what is the moment of that force about this axis, CD? That's the question in this example. So again, the question is that basically if you want to calculate the moment about the CD, about that hinged axis, then first of all you need that position vector or unit vector. You basically need a unit vector along CD dot r cross f. I mean on that f, you need on the line of action of the f, you need any moment arm from the origin. So this is the origin. So from that origin, one of the moment, simple moment arm is AC. I mean this is the moment arm. So let's say AC. So you need basically R AC cross f. So you need basically three vectors. So if you can figure out three vectors and then you take that, you calculate that value, then you can calculate the value of CD. So first of all, let's say, let's try to calculate, let's say, this position vector. This is very simple. R, A, C. So that means C is 0, 0. So what are the coordinates of A? Simply 6. 6i comma 0 0, right? And then let's say if we want to convert this force into vector force, then we need the position vector first, and the position vector is AB, right? That means we need the coordinates of B as well. So what are the coordinates of B? Anyone?
0, 4, 12.
0, 4 and then
12.
12. Yeah, right. So these are the coordinates of B, right? And then if we know that position vector, what will be the position vector? Let's say RBA. RBA. What is the position vector?
-6, 4, 12.
-6, 4, 12. Very nice. Who is the answering?
Sir, Afaq.
Afaq. What's your registration number?
037.
037. Very good. So are you repeating this course?
Yes, sir.
Right. So you have good concept, right? All right. And then again we need the position vector CD as well, right? For CD, I mean for this one CD, again we know the coordinates of C is 0, 0, 0. And then what is the coordinates of D? What is the coordinates of D?
0, 8, 6.
0, no. Okay, y-axis first. Yeah, 0, 8, 6. Right. That's 0, 8, 6. Right. So these are the coordinates. So remaining is to calculate the I mean that UCD. First you need position vector RCD, right? RCD is equal to again Z, because that's the origin. So 0, 8, 6, right? And then you need to calculate its magnitude, and then once you calculated its magnitude, and then you can calculate the unit vector UCD. And then once you calculated this one, you need to put all the three vectors in this equation, and then you can calculate the value of the moment. So first of all, you calculated the position vector RCA, then you converted force into vector by multiplying that scalar with the unit vector, then you convert it into force vector, and then you take the unit vector of CD, and then finally you apply that formula UCD dot R cross F. There should be a bracket, and then you simplify, you get that answer. So that answer was equal to minus 432 pound feet. So do you understand?
Yes, sir.
Right. What about this one? So again, this is related to calculating the moment about certain axis, I think. So we have two wrench, and let's say you want to tighten a pipe, let's say this one, this joint, and one wrench is used for holding, another one is for tightening, I mean applying that force. One is for holding that pipe, another one is for applying that force. To hold that force, you need to, I mean, to hold that pipe, the left hand apply a force Fa, and to rotate or tighten that nut, the right hand that apply a force B at point B, let's say, and various dimensions and angles are given. What you need to figure out is FB is given here. Let's say FB value is 150 Newton. Where is FB? So this is FB. So this value is given, which is equal to 150 Newton. The question is determine the magnitude of the moment produced by this force about the y-axis. So basically you need, first of all, what is the moment produced about the y-axis, right? Also, what is the moment magnitude of force Fa, and again you need to calculate the magnitude of this force, since the moment produced by this force Fb will be equal to that, and then you can, by equating those moments, you can calculate the value of Fa. But first you need to figure out the moment, this one. To calculate this moment, first of all, uh, you need to convert this force, this scalar force, into vector, into a vector, because we know that to calculate the value of the moment about y, what we need is, we need a unit vector along x-axis, which is very simple, which is j. So j dot, and any moment arm, let's say from here to here, any moment arm, uh, and we need that position vector, right? That position vector mean, let's say we need to give the name here, let's say this point is, let's say C, and this point is, let's say D, right? So that means from here to here we have the moment arm, which is on the line of action of the force, but we need this moment arm in the vector form as well as a force in the vector form. So if we can convert this force as well as the vector, then the problem is very simple. Then what we need is, we need, let's say dB, we need that moment arm dB cross F. So simply you can calculate the value of that my. So how to get, first of all, this force vector? How to get this force vector? I think we can use the angles. Like let's say this is z-axis, and let's say parallel to x-axis, we draw a line. Right? This is, let's say, parallel to x-axis, right? So that means this force will have two component. One will be, I mean, this component, and one is along the x-axis, right? And what is the component? This, that means we need this angle first. We need that angle first. Uh, right. What is this angle? What is this angle?
30.
30. 30?
90 होगा सर
90. Why that will be 90? Because that angle
बिकॉज
is,
सर ये एक्स
yeah.
एक्सिस के पैरेलल है और वो वाई एक्सिस के पैरेलल है दोनों लाइंस तो 90
So
डिग्री
yeah, right. This is 90-degree angle, right? And then what about this angle? I mean this angle. Let's say this is 30. This is 30. Let's say if we consider this triangle. Let's say this triangle, right? This triangle. Let's say this is 120, and this is 30, and then what will be this one? This angle.
210, sir.
No. I mean D, consider D, B, and this one, this
30.
triangle.
30 होगा.
Right? This will be 30. Yeah, you're right. I
30.
mean, this is just a triangle. I mean, consider D, B, and let's say name this at T. Let's say this is point T. So D, B, and T. So if this angle is 30, this is 120, then what is that angle? Simply 30. Right? So again, come back to the original triangle, this small triangle. So if this angle is 30, this angle is 90, how much is that angle?
60.
This one? 60. So
60.
this angle is basically 60 degree, right? So now we can resolve the component. I mean, this component will be equal to FB sine 60, FB sine 60, right? And the component along x-axis will be FB cos 60, right? FB cos 60, right? That's cos 60. So that means FB, that force, we can convert into vector. The component which is along the x-axis, that's equal to FB, and the value of FB is 150. So 150 cos 60, and the y component is 0, and then the z component, and the z component is 150 sine 60. So these are the vector force. So we have the three component of the force. Next one is we need a vector here. I mean this vector, the moment of RdB. For RdB we need the coordinates of D and coordinates of B. So how can we get the coordinates of D and B? What is the coordinates of D? What is the coordinates of D?
0, 50, 0.
0, 50, 0. Yeah, that's right. 0, 50, and 0. That's true. And what are the coordinates of B? What are the coordinates of B? I mean, you can reach B. You start from the origin. You have to move in the 50 in the positive y, and then this value, and then this value, right? From here to here is how much? So if this moment arm, if this is the hypotenuse, let's say 300 millimeter, and this angle is 30, then from here to here will be how much value?
300 cos 30.
300 cos 30. Yeah, right. And what about from here to here? 300 sin 30.
930.
Yeah, so the coordinates of the B will be equal to 300 sine 30, 300 sine 30, comma, this is the x-axis and positive one. Then the y-axis is this one, again positive, which is 50. And then finally the z-axis is 300 cos 30. So the remaining is just calculation. I mean, how to get now that RdB? RdB mean B minus D. So you can subtract this one from 0, the 50 from 50, and then this one from 0. So that will be the value of dB, right? You already know the value of J, right? So then you just, I mean, apply that matrix, this one, I mean 0, 1, 0, and then the values of R, and then the values of F, and you simplify, that will give you the value of the My. So similarly, if you come to the that force FB, you can apply the same formula. Like similarly, you can get the coordinates of C. So what are the coordinates of C? What are the coordinates?
0, negative 50, 0.
Yeah, right. 0, negative 50, and 0. So these are the coordinates of Z. Similarly, you can resolve F into different forces. Let's say here you have the 30 angle, right? So let's say parallel to the x-axis, we want to draw parallel to x-axis. Let's say this is parallel to x-axis. Let's say, right, that's parallel. Sorry, this is right. Please, this is touching the force F. So that means that x-axis will be perpendicular to y-axis. So this angle is 90, right? Again, what is that angle? From this force to total angle is 180, because this is a straight, the angle on the straight line is 180, right? So what is this angle?
45.
This angle is 180 minus 135, 45? Yeah, 45. So this is 45, and then this is 45, and then this is 90, right? This is 90, and then what is this angle? I mean, if this is 90, this is 90, this is 30, and then what is that remaining angle?
60.
60.
Yeah, right, 60. So if this is 60, then what? How much is that angle? This much, because this is 195, because 135 plus the 60, 195, 195 minus 180. How much is that? 15. So this small angle is 15 just. Right? That small angle is 15. So now this force will have two components. Right? One of the component will be along the x-axis, right, which is FA cos 15, whereas the one component will be parallel to the x-axis. I mean this one parallel to x-axis, that is in front of the angle, that will be FA sin 15, and whereas this one will be FA cos 15. So you need two component, and then similarly you need the position vector. You know the component of the C. Similarly, you can get the component of the A. I mean, A mean you have to move in the Z direction, then in the X direction. So simply these two component. I mean, minus from here to here minus 15. Then this one, this means the arm is 300. So in front this is 30 degree. So this is cos 300, and this is sine 300. So similarly you can get the coordinates of A. So similarly you can equate moment, this moment equal to this moment, and then you
सर
can get the,
सर
yes,
ये जो बी के एंगल्स हैं
जी
सर
किसके?
इसमें माइनस साइन नहीं लगवाया आपने जो बी के कोऑर्डिनेट्स हैं नेगेटिव जी और नेगेटिव एक्स है
यहाँ पे ये वाले,
हाँ यही
yes,
300
yeah,
साइन 30
yeah,
नेगेटिव
right, you are right. Basically, like we are moving down here, so Z component is negative basically. So we need to put here minus sign, but the other one is positive. This is this is in the, yeah, but we have to go in the negative direction, negative x-axis. So this should also be negative. Thank you for the correction. Yeah, you are right. The sign should be negative. So this way, I mean, all the angle, this 50 angle, the angle that we just discussed, and all the coordinates. And what we need to do, first of all, we need the position vector RCB, and then we converted the two component of the force, and then we take J dot R cross F, right? So this was the moment. So the moment produced by the first range is equal in magnitude to the moment produced by the other one, but opposite in direction. So let's say if this is the clockwise direction, the other will be anti-clockwise. So we have to take the reverse direction, right? And we can equate. And similarly for the other one, we need the moment arm, and then we need the force in vector form, and then both moment are equal but opposite in direction. So we equate. I mean, if this was negative but equal in magnitude, and similarly, so if we solve that, we have the only unknown FB. We simplify, we can get the value of the FA, right? So you understand? I just rearrange. the previous one.
Yes, sir.
Right, and then we have another concept. This is called the moment of a couple. What is a couple? What is a couple?
जब दो फोर्सेस इस तरह मोमेंट जनरेट करें कि दोनों का इफेक्ट एक दूसरे के ऑपोजिट हो.
Now, what is a couple? I'm asking, what is a couple?
Pair couple means
Yeah, yeah, couple mean pairs, but which one specifically? When the two forces are equal and opposite to each other, that called a couple, right? The two forces which are equal in magnitude but parallel and opposite in direction. Let's say this is a force 1, let's say F, this is also F, this is minus F, which is equal in magnitude but opposite in direction. So these forces, these two forces, combination of these two forces is called couple. Now the moment of couple means the moment produced by the couple, right? Right? What is a couple? First, the two parallel forces that have the same magnitude but opposite direction and are separated by a perpendicular distance d. And there is a distance between them because they are parallel to each other. So the moment produced by this couple is called couple moment, right? And there are many examples in our daily life and in our engineering. I mean, just take the example of that steering. In that case, sometimes when you want to turn that, basically you're applying a couple, equal and parallel forces. Similarly, when you are, I mean, riding a cycle, then you are applying a couple, equal and parallel forces. So when there is a turning effect of that forces, when there is a turning effect of that forces, we call moment of couple. And mathematically we can calculate the moment of the couple. Let's say F, there is a perpendicular distance between them, then we can calculate by taking, let's say, any reference O. There is a moment of this force because of this momentum. Similarly, there is a force and there is a momentum because of these forces. So if we simplify, like this one is, let's say, F R cross R B cross F, similarly plus R A cross minus F. And if we simplify F is a common, then we can say RB minus RA, whereas RB minus RAE is simply R. So R cross F, right? So this is R cross F. So simply, if you want to get the moment of a couple, you need one of the force vector, any of them, one of the force vector, and then there should be moment arm which is perpendicular to that. I mean, in 3D, in 2D, this should be exactly the perpendicular distance. But in case of 3 dimension, this R vector is not essentially the perpendicular between the two forces. This could be a vector one. I mean, R could be a vector ones, right? So that's a free vector. Free vector mean that, I mean, moment couple moment is a free vector. That means this R could be, I mean, it should be on the should be touching the line of action of these two forces, because this is a 3 dimension. But in case of 2D, there should be a perpendicular distance between the two forces. Right? This is a scalar formulation I just discussed. In scalar formulation, you just need the magnitude, whereas in the vector formulation, there is R cross F. You'll get the direction as well as the magnitude, right? Normally, in the 2D analysis, we use the scalar formulation, whereas for 3D, I mean, right from the beginning, as I said, in 3D, we'll use vector analysis, right? And how to get the resultant couple, because there could be number of couple acting on a system, so we have to add up. Let's say this is a one of the couple moment, there is another couple moment. I mean, this couple moment is produced because of two parallel equal forces. Similarly, there is another couple which moment produced because of another two set of the parallel equal forces. So how to figure out the resultant couple moment of this system? You have to add up, right? You have to add up, and we have to see, I mean, this is the resultant couple moment, MR. And this is very important that in these cases, you have to see the direction of the resultant moment. Sometimes it could be negative, it could be positive. The positive direction will indicate that the resultant moment is in anti-clockwise, whereas the negative direction of the resultant moment will indicate this is in the counterclockwise direction. Right, let's try to practice a few examples related to the couple moment. Let's say this is you can see this is a system which is ported at 3 point, let's say 1, 2, 3, and several couple are applied. How many couple are applied on the system?
3.
3. Like let's say one is related to F2. So this is F2. There is another force F2 which is parallel and equal in magnitude. This is F2, right? So this is F2, right? And similarly, if this is parallel force, there will be F1. Let's say this is F1, and parallel to this F1 is F1, which is equal in magnitude but opposite in direction. Similarly, let's say this is F3. So the another force F3 is equal in magnitude but opposite in direction. So that means we have 3 couple. So what is the resultant couple? MR. So the resultant couple basically that will be the sum of the couple moment of each one. Let's say M1 plus M2 plus M3, right? M3. So let's try to calculate each moment. For example, let's say related to the F2. So related to F2 mean 450, and what's the perpendicular distance between them?
4.
No.
3. 3.
3. And then we have to figure out the direction as well. So what is the direction of that couple moment? Clockwise or anti-clockwise?
Counterclockwise.
Yeah, counterclockwise. So this is positive, right? This is related to F2. And then let's say see about the F1. F1 is 200, and what's the perpendicular distance?
4.
4. So that means 200 multiplied by 4, right? And let's see the third one. What about the direction of this?
नेगेटिव होगी सर.
Direction is negative because that's clockwise, right? What about F3? That's 300
into
and
5.
what's the perpendicular distance? 5. So 300 multiplied by 5. What about the direction?
Negative.
Negative.
The direction is negative. So that means overall moment, the resultant moment is the sum of these 3. So you have to calculate, right? So you have to calculate. I mean 2 will be negative. I mean this is negative, and 1 is positive. So 2 will be negative, 1 is positive. So overall is negative. So that means the resultant moment has direction in which direction?
Clockwise.
Clockwise, because this is negative, right? Sometimes to to vanish this direction sign, you can put this symbol, like this symbol, right? This symbol indicates that this is the magnitude and this is the direction. Instead of writing complete word like clockwise, you can just put this symbol. That will indicate that the direction is clockwise, right? Right, let's try to solve this one. Determine the
Excuse me, sir.
magnitude. Yes.
सर ये जो रिजल्टेंट मोमेंट है ये स्केलर होगा वेक्टर होगा? ये स्केलर बता रहा है.
Because this is 2D. 2D में will use the scalar notation. For 3 dimension we'll use the vector notation, right? So that
Okay,
means we have the magnitude as well as the direction, right? But if we'll try to calculate in the 3 dimension, then we need each component, like in terms of I, J, and K. You got the point?
Yes sir, thank you.
Right. So let's try to solve another one. Determine the magnitude and direction of the couple moment acting on the gear as shown in figure. So we have a gear here, and one couple is applied. On that couple mean equal and parallel forces. The force is 600 Newton. 600 Newton, and both they are making an angle of 30 degree with the x-axis. So what is the value of the couple? I mean the moment because of this couple. What is the value of that moment because of this couple? Now, can you figure out the perpendicular distance between the two couple? What is the perpendicular? Because to get the moment, we need the perpendicular distance, right? Is that true?
Yes sir.
So, can we figure out the perpendicular distance?
No sir.
No. Then the other way to calculate is that we can resolve the forces into components, right? We can resolve the forces into components. let's try to resolve the components. For example, this force will have one of the component in this direction, x-axis, one of the component in the y direction, right? Similarly, this force will have one of the component in this direction, x-axis, one of the component in the y direction, right? For example, what is the value of this component? What is the value?
600 cos 30.
Yeah, 600 cos 30. And similarly, this component will have 600 sin 30. Right. Similarly, we can resolve this one. What is the value of this component? 600
sin 30.
Yeah. Similarly, this component 600 cos 30. Now we can have, instead of two couple, now we'll have how many couples? Instead of one couple, now we have two couple. I mean, one is this component, this one. So this one, so another one is this one. So that means two equal and parallel forces. And what is the perpendicular distance between them?
0.2.
0.2. So now it's very easy. So 600 cos 30 multiplied by 0.2. What about the direction of this couple? What is the direction of this couple?
Counterclockwise.
Counterclockwise. So this is positive. And then another couple. This is 600 sin 30, 600 sin 30, and the direction is
Negative.
negative. Clockwise. 600 sin 30 multiplied by 0.2. So if negative. So if you add up, that will give you the total couple moment. So if you simplify, the answer will be like 43.9 Newton meter. So 9 Newton meter means that's positive. That means the overall couple moment will be in the counterclockwise direction. So you got the idea?
Yes, sir.
Right. So this is a similar one. Please try to practice this one, because this is a similar one, very simplified form of the forces. So what you need is, you need to resolve each force into component. For example, this force can be resolved one of the component along the x-axis and the one component perpendicular to the x-axis. Similarly, this force, one of the component can be resolved, along the axis and one perpendicular to that axis, right? Similarly, each force can be resolved into parallel and perpendicular to the axis. So you will see that there will be lot of couple. For example, this is 150, there will be another 150 and with same angle. So this is 150 with the same angle, right? So this is minus f, there will be positive f, and the same angle with the vertical one, right? So that means one couple will be because of this force, and another one will be because of this and this. But we cannot find out these directly. Just like the previous example, you need to resolve these two couple. So the couple will be multiplied. So instead of two couple, there will be now four couples. You got the idea?
Yes, sir.
Right.
Yes, sir.
So what about this one? This is the last one, 4-86. Let's say the two gears, they are meshed together. These are two meshed together, and one gear is moving. Let's say this is rotating. This one is rotating in which direction? Can you show me the direction? What is that direction? Counterclockwise. So this is positive couple, right? Because of this couple, the couple is given. But there is another couple, let's say M2, because of this gear. This gear is also rotating because of two parallel and equal forces, and the value of the couple is 20 Newton meter. But the question is, what is the resultant couple moment? And specify its coordinate direction angle as well. So first of all, you need to calculate the resultant couple. So resultant couple mean now you have three dimension, x, y, z. So that means we need to convert each couple moment in terms of vector. So what is M1 in terms of vectors? What is M1? 50K, because this is acting along the z direction. So this is simply the 50K. What about M2? So M2, we can resolve M2 into 3 coordinates, one along x-axis, one along y-axis, one along z-axis. Now, for example, M2 is making an angle 20, right? So for this one, we can resolve this one along this coordinate, right, along this coordinate, as well as along the z coordinates, right, because this is the angle. So using the 20 angle, what is the component which is along this direction? What is that value?
20 cos 20.
Yeah, 20 cos 20, that's true. And what is the value along z direction?
20 sine 20.
Yeah, 20 sine 20. But we need another two component as well. I mean, we need the two component, one along the y-axis and one along the z-axis. Now we can use this component. Now we can use this component, right? The value of this component is 20 cos 20. Now this component is making an angle 30 degree with the y-axis. So that means one of the component will be this one, and one of the component will be this one. I mean parallel to x-axis, right? So that means what is the value of this component along the y-axis?
20 cos 20 cos 30.
20 cos 20 cos 30. Very nice. And what will be the value of the component along this direction? I mean parallel to x-axis in front of that. That will be equal to 20,
20 cos 20 sin 30.
yeah, cos 20 sin 30. Yeah, that's true. So now we have the M2 as well in terms of ijk. So M2 in the vector form, right? M2 in the vector form. So the component in the y direction, this is positive y direction, and the positive y direction value is 20 cos 20 sin 30. So that will be the I part, right? And then the j part mean the y-axis. This is y-axis. Y-axis is negative um, 20 cos 20 cos 30, right? And then the j we already calculated. This is 20 sin 20. So when we have two vectors m1 and m2, what will be the value of the resultant? We have to just add up two vectors m1 plus m2. So that will be the resultant vector. And how can we get the direction cosine? I mean the first component will either you can calculate the magnitude and then you divide magnitude with the component. Like we calculated the m1 first, and m1 was just in the k direction. Then the m2, just I explained that how we figure out the angles of each component, right? So this is in the vector form, and the resultant is just simply the addition m1 plus m2. So this is simply the addition. And then how to get the magnitude of this? You use the square root. So this is the magnitude. And how to get the angle? For example, cos alpha, what was the value of cos alpha? I mean the first component divided by its magnitude, and the cos beta was the second value divided by this one. Similarly, this one, the k value divided by magnitude, and then you take the inverse of the cos, then you can get the alpha, beta, and gamma. So is that clear?
Yes, sir.
Yes, sir.
Right. That's the end of this lecture. Uh, we have one more topic in this chapter. That is, I think, the how to convert the uniformly distributed load into the single load, right? The resultant force.